I just want to show you something that I found really amazing here. This is my oscilloscope. I'm going to show you here my setup first, as you can understand what I'm doing. This is my transistor, my power switch, the circuit, the IGBT drivers, which I'm not using for now. Okay, this is my frequency. This is the frequency range switch. This is a diode in series with the MOSFET. Okay, and the primary. That's the primary, the secondary, and these are the charging chokes. Okay, which are on the same transformer, with the taps on the second choke. Okay, and in series I have another choke. Okay, and going to the water, but this is not the most interesting thing for now. This is my alternator with the rectifiers here outside, and the motor which is driving the alternator. Okay, see my battery. Okay, my multimeter. This is a iron powder core, which I'm going to use it maybe later. I'm going to make further tests with it. And this is a new bipolar coil which I made with iron rods inside. Okay, and I made it with a wire which I had here, about 20 meters of wire. You see, these are 9 square bars, you know, inside. Each one is insulated from each other to avoid eddy currents. But this isn't the cool thing yet. And here it is. This magnet. Look at it. I'm going to get this on the primary of the transformer, and I will have a change in amp flowing from the battery and a change in the voltage going through the water. When I approach this to this primary coil in the with the right polarity, it will help to restrict the amps flowing from the battery, and at the same time it will raise the voltage through the water. Okay, here it is. Here my voltage, you see, 7.2. So I'm going to turn on the alternator for the alternator voltage keeps constant, okay? No problem. And here it is. I get this here, and you see voltage raised. Gets 12 volts. 12 volts. And if I adjust it, the reverse polarity, you see voltage is not really much higher. Without the magnet, with the magnet with the wrong polarity, you see, and with the right polarity. You see, if I adjust it very well, voltage will become the higher possible, almost twice the voltage. You see? If I adjust the frequency, okay, it actually could get up to 13 volts, but 14 volts. It's not doing this anymore. I don't know why. frequency. Okay, no problem. The important thing is that you see the effect, okay? The effect of the magnet. Basically, it will allow the field to collapse in one direction while opposing the collapsing of the field in the other direction. So you get this effect, okay? Now I'm going to show you the amp flowing from the battery while I add the magnet there, okay? Switching the voltage to ampere meter. Okay, take this out of here and put it here. Okay, wait a minute. Here it is. Now it is connected as an amp meter. You see, and I will just touch this here to turn on the circuit, okay? Because I don't have a main for holding that there. Okay, now I turn on the circuit. You see, no flowing. I touch here, I touch here. You even heard the noise. Look, 3.5 amp flowing from the battery. Okay. Now I take out this magnet and touch again. 3.247. Now I put the magnet again, but with the, let me see if the polarity is right. Yes, look, less than 1 amp. You see? Look with the alternator, turn it on like it was before. Okay. Look, 1 amp. Okay. Okay, amp flow without the magnet. Okay. Here it is. Did you hear the sound of the alternator? Change it. Look if I use the other polarity. Amp flowing without magnet, with the magnet, without the magnet, with the other polarity of the magnet. You see? See the difference?